Okay, so in this lesson, we're going to talk about finding the difference quotient of a linear function and a quadratic function. And so those are the only two functions we're going to find the difference quotient of. So again, we're going to find the difference quotient of a linear function and a quadratic function. All right, now the difference quotient, when we talk about the difference quotient, when you look at it, the difference quotient just measures the slope of a secant line. Measures the slope of a secant line. That's what we define the difference quotient to be. It measures the slope of a secant line. Now you may say, what is a secant line? All right, well, let's look at a quadratic function for a moment. So I'm going to go ahead and kind of, at this point, derive the difference quotient. So let's kind of look at that idea. So let's look at the derivation, so to speak, of the difference quotient. Derivation of the difference quotient. All right, so, and again, we're going to look at this in terms of a quadratic function. So if I have this coordinate plane, and let's say that this is my quadratic function. Looks something like this. All right. Now, remember the graph of a quadratic function is a parabola, and here's my y-axis, and this is my x-axis. Okay, so I'm going to look at a line. Now, a line that goes through the graph and intersects it in more than one place. So you see this line intersects the parabola in two places. So this line is called a secant line. So that's my secant line. And notice there are an infinite number of secant lines in this plane that goes through this parabola in two places. All right, so that's a secant line. Now let's look at the slope of a secant line. Now notice there are no numbers here. I did that on purpose. So you can't say this is 1, this is 2, this is 3, and so on. All right. So remember, when finding the slope of a line, so the slope of a line, remember, is rise over run. And the formula when 2 points are given is y2 minus y1 over x2 minus x1. All right, so we're looking at the quotient. Remember, division, quotient. We're looking at the quotient of rise and run. So the rise is the change in y coordinates. The run is the change in x coordinates. Okay, now let's go back and look at these 2 points here. So I'm interested in these 2 points. All right, if this is my x coordinate, then the coordinates, and let's call this function f of x. The coordinates of that point then would be x, and so let's suppose this is 2. To find the y coordinate, you would say f of 2. Okay, so that'll be f of x. So the coordinates of this point is represented as x, f of x. All right, now let's look at this point here. So let's say that the distance from here to this point here, let's say that distance is h. All right, now I want you to think about this. If this is x and this distance is h, then what do you think the x coordinate of this is? So for example, if this is 3 and that distance is, let's say, 4, do you all agree that 3 plus 4 is 7? That would be the x value here would be 7. Okay? All right, but I don't know that this is 3, and I don't know that this distance is 4. So in general, I'm going to say if this is x, and this distance is h, then this x value here has to be x plus h. Just like I said, 7 here, I got by saying 3 plus 4. All right, so my in terms of the coordinates, the x coordinate here would be x plus h. And again, to find the y coordinate, I do the same way. I'm going to say f of x plus h. Okay? All right, so if this is x, then this has to be x plus h. If this distance is h from x, then the x value here is x plus h. And so if this is x, then my y-coordinate has to be f of x. And if this is x plus h, then the y-coordinate is going to be f of x plus h. And so the formula then, the slope then, using this formula, rise over run, so that's where I subtract the y-coordinates. So you're going to say f of x plus h minus f of x divided by, and then you subtract your x-coordinates. So x plus h minus x, and notice the x's add up to be 0, and so all you're left with is this. You're left with f of x plus h minus f of x all over h, and that's the difference quotient. So that's the slope of that secant line, which we call the difference quotient. All right. So we call it the difference quotient because look, the subtraction, the operation here is subtraction, and you're looking at a quotient. All right. So that's the formula for the difference quotient. So you're going to say f of x plus h minus f of x all over h. Okay. All right. So let's go back now and discuss what we're interested in. So I am interested in finding the difference quotient of a linear function and a quadratic function. That's what I'm interested in. And so I know that the difference quotient is the slope of the secant line. All right, so the formula for the slope of a secant line through any function, again, I'm just interested in these two, is this. It's so the difference quotient will be, difference quotient is going to equal f of x plus h minus f of x all over h. That's your difference quotient. Okay? All right, now let's kind of review this idea here for a moment. So if I have this expression, so let's say number one, I have f of x is, let's say, 5x plus 2. Okay? And for right now, all I'm doing is reviewing this idea here. And if I want to find f of x plus h, again, wherever I see the variable x, I'm going to substitute x plus h. That's what I do. So I'm going to get 5 times x plus h plus 2. And then I distribute because you want to get rid of the parentheses and combine like terms. So I'm going to get 5x plus 5h plus 2. And that's all you can do because these are not like terms. Okay? All right. So if f of x is this linear function, then f of x plus h is this. All right, so now let's look at a quadratic, see how that looks. So if f of x, let's say, is negative 3x squared plus 7x minus 2, let's say. So let's say that my function's this. And I want to find f of x plus h. That's what I want to find. Because remember, if I'm going to be finding the difference quotient, one of the things I'm going to always find is this. That's what I'm always going to find first. Okay? All right, so again, the idea is where we see the variable x, I'm going to substitute x plus h. So again, you're going to do this. You're going to say negative 3 times, in parentheses, I'm going to be substituting x plus h. So I get x plus h. But remember, that x here, and remember, you're substituting x plus h, has to be squared. So it's got to look like this. Negative 3, and remember, that's x squared, so, but I'm substituting x plus h, and I'm squaring it. Plus 7 times x plus h, and then minus 2. Now, that's where I'm at. You're not done. There are a couple more things you got to do, but that's where I'm at this point. All right, now, let's look at this. Okay. Now, remember, we have to square this binomial. We have to square this binomial. So let's go ahead and off to the side, and let me go ahead and do that here. Let's do that here. So go off to the side and square x plus h. Well, remember, x plus h squared means x plus h times itself. And so I'm multiplying two binomials, so I'm going to use the FOIL method. So when I use the FOIL method, I get x times x is x squared. The outer is xh. The inner is also xh. And the last, that's the inner, and the last, h times h, is h squared. Combining like terms, I get x squared plus, and then there are two of these, to get 2xh plus h squared. Now that is just this, okay? It's just this right here that I'm boxing in. So that right here is the same thing as this. So I'm going to substitute this in place of this now. So I'm going to say negative 3 times, in parentheses, x squared plus 2xh plus h squared. Now I'm going to go ahead to this point and distribute the 7. So I'm going to get plus 7x plus 7h minus 2. And I'm going to come back and distribute the negative 3 now. And so I get negative 3x squared. And a negative 3 times 2xh is a negative 6xh. And then negative 3 times h squared is a negative 3h squared. And then write everything else over. And then notice there are no like terms, so you're done. Okay? All right, now, before we go on and actually do a problem where they ask you to find the difference quotient, remember, one of the things you got to do is find f of x plus h. And so for us, when we're looking at our functions, it's either going to be linear, which is always the easy one to deal with, or it's going to be quadratic. Now remember, when it's quadratic, there's quite a few things you have to do, especially this point here, because you're always at some point going to be squaring x plus h, and that's how it's always going to look. Whenever you square x plus h and you FOIL it, you're going to get x squared plus 2xh plus h squared. All right? Okay, now let's actually do a few problems. So the directions are going to say this. The direction is going to say, find the difference quotient. Find the difference quotient of, and number 1. Let's say I want to find the difference quotient of f of x equal negative 6x plus 2. All right, now notice this is a linear function, so that's going to be the easy kind. So let's go ahead first of all and write out what the difference quotient is. So the difference quotient is this. It's f of x plus h minus f of x all over h. And remember, that just measures the slope of a secant line, which you're going to use in either business calculus or calculus for engineers. So that idea is going to come back again. So this idea deals with slope of secant line, which corresponds with the derivative of a function. So you're going to talk about derivatives when you get to business calculus or calculus with engineering, for engineering. Okay, now, difference quotient. So notice that if I want to find the difference quotient, notice I have a numerator and I have a denominator. So I'm looking at a slope. That's what I'm looking at. So what I would do first is this. If I look at the numerator, there are several things you got to do. You got to find f of x plus h first. So I would think of this in steps. So step 1 is the way I would think about this. Step 1, find f of x plus h. That's what I would do. I would find this first. Okay? So just like we did a while ago, remember this right here? That's that idea. So find f of x plus h. Where we see the variable x, you're going to substitute x plus h. That's what you're going to do. All right, so I'm going to get, if I want to find f of x plus h, wherever we see the variable x, and I see it here, see that's the only place I see it on this side, I'm going to substitute x plus h. So that's going to equal negative 6 times, in parentheses, x plus h. But don't forget you're adding 2. So you got to say plus 2. Now go ahead at this point and distribute. So I get negative 6x minus 6h plus 2. All right, now notice that part here, this part right here, that is this part of the numerator. Okay? Now here's what I would do for step 2. For step 2, I would say this. Step 2 would say find the numerator now. So in other words, the numerator being f of x plus h minus f of x. Okay? All right, so here's what I would do. All right, so I know what f of x plus h is now. For this function, f of x plus h is this right here. So that's going to equal, see, this is this. So you're going to say negative 6x minus 6h plus 2. So it's a good idea to kind of make a note here, like I did, a little brace, saying that that is this, which you got from step 1. But here's where the issue is going to come in. So you see you have to subtract f of x. Well, f of x, remember, you know what f of x is. That's the function. So this is f of x. See, minus f of x. Well, there's f of x right there. All right, now here's the mistake you're going to make. You're going to do this. Some of you are going to do this, and and that's not correct. You're subtracting all of f of x, every term. So if you write it like this, the only thing you're subtracting is that first term, but you also have to be subtracting the second term. So always put that in parentheses. That's the point I'm making. So when you rewrite f of x, when you say minus f of x, subtract f of x, make sure you put f of x in parentheses. Now you're going to get rid of the parentheses, just like you got rid of the parentheses here. So you can distribute a negative through here. So I get negative 6x minus 6h plus 2. And when you subtract a negative 6x, that becomes plus 6x. And when you subtract a negative 2, I'm sorry, when you subtract a positive 2, that becomes a negative 2. Now listen carefully to this part. If you are doing this correctly, and again, we're dealing with polynomial functions here. And in our case, it's going to be linear and quadratic. If you're doing this correctly, every term, and notice there are 1, 2, 3, 4, 5. There are 5 terms here. Every term that does not have the variable h. See, this term has a variable h. This term does not. Those terms that do not, its opposite better be listed somewhere else over here. So notice the opposite of negative 6x is a positive 6x. And when you combine like terms, that's 0. Over here, you have a positive 2. Its opposite is a negative 2. And when you add them up, that's 0. That's always going to occur. Always. And so now the only term left is negative 6h. Now notice, so this right here, f of x plus h minus f of x, turns out to be only negative 6h. And that is your numerator. So you found the numerator. All right, and then finally step 3 would be where you would find the quotient. Find the quotient. All right, so here we go. So the quotient, you found the numerator now. Step 2 is your numerator right here. That's your numerator. But then you're also dividing by h, and then you reduce. See, I can reduce here. The h's divide out, and you're just left with negative 6. All right, so that's your difference quotient. Now you're going to see that's going to mean something next semester. You're going to see what it is that really represents next semester. Or whenever you take business calculus or engineering calculus or calculus for science majors. All right, so negative 6. All right, now the way you're going to write it is going to be this. You're going to say something like the difference quotient of f of x, which equals negative 6x plus 2, is blank negative 6. That's what you say. Okay? All right. But notice it is important when you do the worksheets, and when you take the test, that you do this in steps. It is important that you think of this in terms of steps. Step 1, find f of x plus h. Step 2, find the numerator now. And then step 3 is find the difference, find the quotient. So whatever you found in step 2, you divide by h. And then simplify if you can, reduce. Okay? All right, now let's look at a quadratic one. All right, a quadratic one. So this will be number 2. Okay, number 2. So let's suppose in number 2, we had this. All right, so let's suppose we had f of x plus h is equal to 5x squared minus 2x. All right? Now notice this time it's quadratic. It is quadratic, so you're going to notice in a little while that since it's quadratic, I'm going to have to use this idea right here. Okay, every time you see a quadratic function, you're gonna remember, you're gonna recognize, oh, this looks similar. This looks like something I've already done. It will be, because you'll be squaring x. And when you for x, remember you're gonna substitute x plus h. All right, so let's look at this. So remember, the difference quotient, we want to find the difference quotient now. So the difference quotient is this, f of x plus h minus f of x all over h. All right, so let's do the steps. Step one is to find this. So always think, step one. What is step one? Well, step one is to find f of x plus h. Now, that's the one where you probably have the most work, let's say. All right, so where we see the variable x, and I see it twice, here and here. So where we see the variable x, you're going to substitute x plus h. Now always remember, when you substitute x plus h, put that in parentheses. So I get 5 times in parentheses x plus h, 5 times in parentheses x plus h, but that's being squared, minus 2 times in parentheses x plus h, okay? Now let's go ahead and simplify this. All right, now notice again, I am squaring x plus h. So remember, order of operation, don't multiply, don't distribute the 5 first, because this is not 5 times x plus h, this is 5 times x plus h squared. So the order of operation says I have to do exponents first before I multiply. All right, so let's go off to the side now and figure out what x plus h squared is. Let's go ahead and do that, what x plus h squared is. All right, so I have x plus h squared, which means x plus h times x plus h. But remember, we did that a while ago. Remember that? That was this. So you FOIL it out, and if you don't remember, and most of you won't, which is fine, you just FOIL it out. You have the time. X times x is x squared. The outer is xh. The inner is also xh. And the last, h times h, is h squared. Combining like terms, I get x squared plus 2xh, and then plus h squared. Notice that's what we got here when we did this. Remember, this was also quadratic. All right, now, notice though that this, always look what you have, that this is just this right here. But remember, what else am I doing to x plus h squared? I am also multiplying it by 5. So now you got to say 5 times, and remember, this is now this trinomial. So you write it, x squared plus 2xh plus h squared. And then let's go ahead and distribute here. Minus 2x minus 2h. Now again, you couldn't distribute here. You may say, why is it that I can distribute here, but I could not have distributed here first before squaring? Because the order of operation says I have to square first, then multiply. Here, you see the exponent's 1, so x plus h to the first power is still x plus h. And so you distribute. Now I'm going to distribute here, and so I get 5x squared plus 10, 5 times 2 is 10, xh plus 5h squared minus 2x minus 2h. And none of these are like terms. Okay, now remember, all I did so far was find this part. So quite a bit of work, and many places where you could make an error. So you really need to be careful. You need to be careful. All right, so that's here. All right, so it's step 1. Step 2, remember, is to find that numerator now. So you find the numerator. So you're going to find f of x plus h minus f of x. All right, well, this part always comes from step 1. That's this. That's all these terms. 1, 2, 3, 4, 5. So I'm going to say 5x squared. I'm just rewriting this. That's this. Plus 10xh plus 5h squared minus 2h. I'm sorry, minus 2x minus 2h. And I ran out of room here. But you are subtracting. Always remember what you're subtracting, though. Remember, that is just this. But you're subtracting f of x. I ran out of room. So you're subtracting f of x. You put that in parentheses. And remember, f of x you already know. You know what f of x is. That's this function right here. So that's going to be 5x squared minus 2h. So you have f of x plus h. Remember, this is f of x plus h minus f of x. Now let's go ahead and distribute the negative here. All right, now so I'm going to rewrite this part, 5x squared plus 10xh plus 5h squared minus 2x minus 2h. And then when I distribute, that becomes a negative 5x squared. And then when I distribute a negative through here, a negative times a negative is a positive, so that's positive 2x. Now, you can always check yourself, because at this point, when you are done, when you've done step 2, then every term that does not have an h in it, its opposite better be listed. So 5x squared and a negative 5x squared is 0. This has an h, so I'm not going to do anything with it. This has an h, I'm not going to do anything with it. This does not. So a negative 2x and a positive 2x is 0. So it's negative 2x. Its opposite better show up, and it does. And this has an h. All right, so there's nothing else you can combine. So notice I have 3 terms left. 1, 2, 3. What do you notice about all of these 3 terms? You notice that they all have h in common. So what I'm going to do is this. I'm going to go ahead and factor out the h. So I'm going to say h times 10x plus 5h minus 2. All right, so that's going to be important in a little while. You're going to see why. So notice that you're left with 3 terms, and they all have h in common, so I factor out the h. So whatever is left, these 3 terms is this, because h times 10x is 10xh. H times 5h is 5h squared. And then h times a negative 2 is a negative 2h. All right, so that's step 2. Now step 3, remember now, is to find the quotient. Find the quotient. So that's the numerator, which is this, h times 10x plus 5h minus 2 divided by h. And now do you see why I factor out the h? Because these h's divide out, and you're left with 10x plus 5h minus 2. So that's your difference quotient. So you're going to say the difference quotient of f of x, which equals 5x squared minus 2x, is this. So you're going to say 10x plus 5h minus 2. All right. Now again, that's going to mean something in another course. But before you get to that course, you have to know how to find the difference quotient algebraically. All right, so that's number 2. Let's look at one more function that's quadratic. All right, so notice that this quadratic function had 2 terms. Let's do one with 3. All right, so it'll be number 3. So let's suppose in number 3, our function's this. So let's say we had f of x plus h is equal to negative 6x squared plus 5x minus 7, let's say. All right. Okay. So I have this quadratic function. I know that it's going to be a lot of work, because notice that this was a lot of work. See, when I found the difference quotient here in number 2, you had step 1, but notice how important it was to write each step like I did. Okay, so it's very important. You say step 1, and then you do this. Step 2, you do this. Okay, and then step 3, you do this, reduce, and you have your answer. You just got to say it. All right, so same thing. So if you look at it, let me go ahead and kind of zoom out. So if you look at it, you'll see that it took almost a whole page. You see it? It took almost a whole page. All right, so let's look at another one. So let's look at number 3, and that was the one. Number 3 was the one that had 3 terms. Okay, this right here. All right, so let's find the difference quotient. So remember, the difference quotient is this. It's f of x plus h minus f of x all over h. So remember that, oops, sorry. So remember that came from this. That's the way we derived it. Okay, so remember step 1? Always remember, okay, what's my first thing I'm going to do? Well, the first thing I'm going to do is find this part of the numerator. All right, so let's find step 1. Let's find f of x plus h. So again, just like before, wherever I see the variable x, here and here, I am going to substitute x plus h. All right, so I get this. I get -6 times in parentheses x plus h, but remember I'm squaring that, plus 5 times in parentheses x plus h, and then minus 7. All right, so always make sure you see what you have. Remember, this is, oh, sorry, I forgot the negative right here. All right, so -6 x squared, but remember in place of x, I substitute x plus h plus 5x, but again, in place of x, I substitute x plus h, and then minus 7. Okay, now we have to look at this first. All right, so I go off to the side, and I figure out what is x plus h squared. But remember, you're always going to have this. And so if you can remember that x plus h times itself is x squared, plus, remember, the out and the end are the same, so you can say 2xh, and the last is h squared. That's what it always equals. So this right here is just what's inside this box. So this becomes -6 times this trinomial, x squared, plus 2xh, plus h squared. Now let's go ahead and distribute this. So it'll be plus 5x, plus 5h, and then minus 7. Distributing this, I get, distributing the -6, I get -6x squared. A -6 times 2 is a -12xh. And then a -6 times h squared is a -6h squared. And then write everything else over, plus 5x, plus 5h, minus 7. Okay? All right, now I have 1, 2, 3, 4, 5, 6. This time I have 6 terms, none are alike. So I can't do anything else to it. So all I found was this part right here of the difference quotient. So this right here is all of this for that function. All right, now step 2 is to, remember this was just step 1. Step 2 is to find this numerator now. So actually subtract f of x plus h. So step 2 is to find f of x plus h minus f of x. So basically you're finding the numerator. Well, remember though, this right here is always from step 1. That's your step 1. That's this. So let's just rewrite all of this. -6x squared minus 12xh minus 6h squared plus 5x plus 5h minus 7. Remember that is just this. But remember, you're subtracting f of x. You're subtracting f of x, this right here, which is this. This right here. Remember, this is f of x, right? So that goes here now. Minus 6x squared plus 5x, that's a 5, and then minus 7. Now we're going to get rid of the parentheses. We're going to distribute the negative through these through that parentheses. All right, so now I'm going to get this equals. I'm going to write all this over. -6x squared minus 12xh minus 6h squared plus 5x plus 5h minus 7. And then when I distribute, the opposite of a negative 6x squared is a positive 6x squared. The opposite of a positive 5x is a negative 5x. And the opposite of a negative 7 is a positive 7. Now remember, always remember, since in this section all I'm looking at are polynomials, linear or quadratic, that at this point, every term that does not have an h, the variable h, in it as a factor, its opposite will be listed somewhere else. So you see how this is negative 6x squared? Well, I better have a positive 6x squared somewhere, and I do. It's right here. So negative 6x squared and a positive 6x squared, 0. All right, if I look at this one, that one has a factor of h. I'm going to leave it. That has a factor of h. In fact, it has 2 of them. I'm going to leave it. This does not. So a positive 5x, its opposite better be somewhere else. And it is. It's right here. That's 0. This has a factor of h, so I'm going to leave it alone. This does not. So a negative 7 and its opposite, positive 7, adds that to be 0. So notice I have 3 terms, 1, 2, and 3, that have a factor of h. So at this point, I'm going to factor out an h. And remember why I did that earlier. I did that earlier. Remember when I factor out an h? So that this factor will reduce with the h that's in the denominator. That's the only reason. Because you want to reduce. You want to simplify. Okay, so at this point, I'm going to go ahead, since these three terms have the variable h as a GCF, I'm going to go ahead and factor out the h. So that's going to be h times negative 12x. So right here, h times a negative 12x is a negative 12xh minus h times a negative 6h. H times h is h squared. And then plus 5, because h times 5 is 5h. That is step 2. And then finally, step 3 is where you find your numerator. So you find your numerator. But remember, that numerator is the part you get from step 2. Well, that's this. So that's your numerator of the difference quotient. So step 3, you find the quotient. And so in this case, the difference quotient. And so you're going to say h times negative 12x minus 6h plus 5, and all of that's being divided by h. So divide by h, and at that point you reduce. And so now your answer is this, negative 12x minus 6h plus 5. And so you're going to say the difference quotient of my function f of x, which is negative 6x squared plus 5x minus 7, is blank. And in the blank you write this, negative 12x minus 6h plus 5. Okay, so but before I go on, notice that whenever it is quadratic, notice it takes almost a whole page. Step 1, step 2, and then step 3. And what you get at the end of step 3 is your difference quotient. Okay. All right. So the one in your worksheet. So notice in your worksheet, when you do this, so notice that the first one is linear, and numbers 2 and 3 and 4 are quadratic. Okay? All right, so that's the end of this lesson. Now, next semester is going to become, when I say next semester, I mean whenever you take business calculus or calculus for science majors, it's going to become clearer what this difference quotient means. All right, so that's the end of this lesson.